A data model commonly used by traditional analysts and database analysts is called the Entity Relationship Diagram, or ERD. The ERD is not a UML diagram, but it is very commonly used, and is quite similar to the UML class diagram. So on the entity relationship diagram, rectangles represent data entities. And the lines connecting the rectangles shows the relationships among data entities. So again, the rectangles later, as you will see in our examples, the rectangles represent data entities and the lines represent relationships among the data entities. So this figure here shows an example of a simplified entity relationship diagram with two data entities, the customer and order. So each customer can place one or many orders. And each order is placed by one customer. So the cardinality is one to many in one direction and one to one in other direction. So the crow's feet symbol, so this one, on the line next to an order data entity indicates many order. But other symbols on the relationship line also represent the minimum and maximum cardinality constraints. So again, in these two data entities, an order must be placed by exactly one entity. So this symbol here, a bar right here, represents only one. And the symbols here, so when a customer can place 0, so the symbol here represents 0 or more the order. So the crow's feet symbol here represent many. So this figure here shows an explanation of ERD relationship symbols. So the model in this figure actually says that a customer places a minimum of 0 orders and a maximum of many orders. So going back to the symbols, this bar here symbolizes exactly 1, so that is mandatory, and this symbol here represents 0 or more, and more is optional. And the symbol here, so a bar and a circle represents 0 or 1, and 1 is optional. And the symbol here is 1, it represents 1 or more, and more more is mandatory. So this figure right here shows the model expanded to include the order items. One or more specific items included on the order. So each order contains a minimum of one and a maximum of many items. There could not be an order if it did not contain at least one item. So for example, an order might include a shirt, a pair of shoes, or a belt, and each of these items is associated with the order. So this example also shows some of the attributes of each data entity. So a customer has customer number, a name, a bill address, home or office phone number. So each order, and there could this symbol here represents that there is only one customer, and then each order has an ID order number, an order date, and amount. And there could be more attributes regarding order, and this symbol here means that a customer can place 0 or too many orders. So this symbolize 0 to many associations. So each order, so per order, an order could be a minimum of one. Now each order item could be a minimum of one or a maximum of many order item. So the order item has attributes of the item number, the quantity, and price. So again, one customer can place many orders. So for example, this particular order is let's say a t-shirt. So the customer cannot it's possible that the customer might not order a t-shirt or might order a lot of t-shirt, and a t-shirt can have one item left, or there could be a lot of item left. Okay, so going back, this symbol here, PK, represents primary key. So as you can remember, the primary key or the identifier identifies or the uniqueness of the thing. So in this case, the customer has a unique key or unique identifier. Each customer has different customer number. The same with the order. An order has also different primary keys, different unique keys that identifies that particular order, and each item in the order also has their unique keys or primary keys. So they have unique item number. This figure here shows how the actual data in some transactions might look. So example, John is a customer who has placed 2 orders. So the first order placed on February 4, that is for 2 t-shirts and 1 belt. So the second order placed on March 29, so for a pair of boots and 2 pairs of sandals. So another customer is Mary. So Mary is a customer who has not placed any orders yet. So remember that a customer might place 0 or more orders. So therefore, Mary is not associated with any orders. And finally, Sarah placed an order on March 30 for 3 pairs of sandals. So the diagram here is sometimes referred to as a semantic net. So a semantic net is a graphical representation of an individual data entity and its relationship with other individual entities. So it shows specific objects that belong to a class or data entity and the links among them. So a semantic net is useful for thinking through and verifying the entities and relationships in an entity relationship diagram and the classes and associations in a class diagram. So another example is shown in this figure. So this is an ERD for a bank. So take a note that each branch can have 0 or many accounts and each customer can have 1 or many accounts. So note that a customer must have at least 1 account. So the meaning behind this is that the bank would not add a customer unless he or she was adding an account. But also, the customer can open many accounts. And then also take a note that each account can have at least 1 transaction. So the meaning behind this is that when you open an account, that will require an initial deposit. But also, can have many transactions in 1 account. You can deposit money or withdraw money. So that is for 1 account. And take a note also with the attributes for each entity. So a customer must have a unique customer number and information such as name, address, and phone number. And each account also have a unique account ID, account number. So, and each account have type, or what kind of account type. Could it be savings account or other type of account? So, and then also the date opened and the balance. And then also each transaction has a unique ID. And then an attribute also for a transaction is a date, transaction type, and transaction amount. So it is important to recognize that questions about the cardinality and minimum and maximum cardinality constraints that you need to discuss and review with the stakeholders.